Hello, everyone, and welcome back. Up next, we have Bastian Köcher, one of our core developers at Parity, and he's going to be talking about launching the first Parachain test network. I'll let you take it from here, Bastian.
Yeah, thank you, Carol. And hi. Yeah, I want to talk about, or my talk is called Run, Learn, Fix, and Repeat, launching the first Parachain test network. My name is Bastian Köcher, and I'm a core developer at Parity Technologies. So let's first start with an overview of what I want to talk about. It's first I want to give you an understanding what are Parachains, what is Cumulus, and then I will give you some brief overview of how was the way to the first Parachain network. And last but not least, I want to talk about Rococo, the first Parachain test network. So what are Parachains actually? Parachains are blockchains, as you probably know, but they are special as they are being connected to the so-called relay chain. And when being connected with the relay chain, they share the security. So that means shared security, so that if you want to, for example, attack your Parachain, if somebody wants to attack your Parachain, it needs to attack the relay chain because the relay chain secures your Parachain. So here I got a rough overview of what is Polkadot, what are the Parachains, what is the relay chain. First, we here have the relay chain with these white points or here and here. Sorry, and the relay chain has attached staked validators, and these validators are running for the relay chain. Each of these validators is always assigned to a certain parachain, and here you see the parachains, and then each parachain has each parachain has its own parachain network. That means you have several nodes, all are being connected to each other, and receiving transactions, providing RPC and all that stuff. But then you have these special nodes called collators, and these collators are the validators of a sovereign blockchain. So that means these collators are responsible for building blocks. And now that's the next part I want to give you, or want to give you an overview of how does block building works for a parachain. First, you have these collators here in red, and these collators are building these called proof of validity blocks that are or a proof of validity block contains the parachain block itself and the so-called witness data, and this witness data can be used to validate this block, but more later. And the collators announce these proof of validity blocks to the Parachain validators, and the Parachain validators then decide, okay, I want to fetch this POV block and start validating it. And after that, after the validator has finished the validation, can fail because there's something is incorrect with the POV block, then it should be rejected, or it's a valid block and then it's approved. And and whatever the result is, the result is being gossiped between all relay chain validators, and the relay chain validators which are assigned to the same parachain will take that and recheck or revalidate this POV block, so that in the end you have all the parachain validators are revalidating the results from each other and sending out these messages or these approval messages, and the validator from the relay chain that's responsible for building the relay chain block will count these approvals, and the one with the most approvals will be included in the relay chain and is the next canonical block of the parachain. So now you could have the question, what happens on a draw? So if two POV blocks have the same number of approvals, okay, then the relay chain block builder will just toss a coin and choose one of these blocks. So now we have seen the authoring logic from the from the relay chain side, but you can also have authoring logic from the Parachain side. So like in a normal sovereign blockchain, you can use any or almost any consensus algorithm like BAPE or proof of work or whatever consensus algorithm you come up with. So, and if you use an authoring logic on your Parachain, it has several advantages. At first, you significantly reduce the number of POV blocks being produced, because from the relay chain model, or from the relay chain side, you could have 1 million collators, and each collator building a block. So you would have 1 million collators, 1 million blocks. But the relay chain in the end reduces that number to the number of Parachain validators. So, for example, you have 5 Parachain validators. So from 1 million in the end, only 5 are being checked, and the rest is thrown away. And that's a lot of wasted energy and a lot of wasted resources. And also, if you have your own authoring logic, it gives you better incentivization strategies to pay your collators, because of why should I build blocks for your Parachain? What's the benefit when I am just one of a million and the chance that mine is included is very, very low? But in the end, however, what you do, the relay chain is the one that decides which Parachain block decides which is the canonical one. So, for example, if you use BAPE and have a secondary and have BAPE with secondary and primary slots, and both are produced a block, then the relay chain decides which one is included and not your Parachain. So that was it about what are Parachains. Now I want to get to what is Cumulus actually. So as hopefully all of you know, we have Substrate, this blockchain building framework, and so we took Substrate to build Polkadot. And you probably will take or took or whatever will do and build a blockchain maybe, and will also use Substrate. So then you have your own blockchain running and you're happily, and then you decide, okay, now I want to be a Parachain. Then the question arises, how can I transition my blockchain to a Parachain? Because before I had only my own blockchain network, my nodes were all connected to each other, but if you're a Parachain, you also need to be connected to the relay chain network, so to Polkadot, and talk to the Parachain, to the validators and all that stuff. So how do you do that connection? And that's what Cumulus is for. So Cumulus is itself built on Substrate and on Polkadot. It takes the interfaces that are provided or required by Polkadot, that are built on top of Substrate, and provides you with primitive types that implement these interfaces, so that you can just take your Parachain and stick in, for example, the Parachain consensus algorithm, the Parachain network and stuff and all that stuff. Just stick that into your node implementation, and then that's it. And then you can start being a Parachain. Then you can go to the relay chain, get a slot, and live a life as a happy Parachain. So now I want to give you a really brief overview of how do you transit, or how can you convert your runtime, your Substrate-based blockchain to a Parachain. So in Substrate in Substrate you have the runtime, and that encapsulates the business logic. And the runtime is the so-called state transition function. That means you have an initial state, then you put data, then you put transactions in, and in the end there comes the state out. So the relay chain is responsible for checking these state transitions, and to check the state transitions, it has the so-called validation code that's being provided at the registration of the Parachain and can later also be upgraded. And that is just a Vasa block that exposes a validate block function, and this validate block function just gets the validation data and gives back a validation result. That's it. That's everything Polkadot requires. And Cumulus provides you with a macro for your runtime that extends your Substrate runtime with this validate block function, so that in the end you will use the same runtime for building blocks and for validating them on the relay chain side. And so the validation can then be compared to like, it's the same as importing the block with some special bits around setting up the state. So that was it about Cumulus. Now I want to get to or talk about the way to the first Parachain network. It all started like almost 1 year ago on the 22th of October. There we had the first running or the first Cumulus-based running Parachain. Then on the 22th of May this year, we were able to send messages from the left window from a Parachain to the relay chain. So we could transfer a token from the relay chain to the from the Parachain to the relay chain. Sorry. So, and after that, the next step was sending messages actually between Parachains. So that means you could send a message from Parachain A to Parachain B. That is shown here. So that was the rough timeline from getting to the first initial from the first running Cumulus Parachain to sending messages between them. But between them, we had done a lot of stuff. We released Polkadot, we released a lot of Substrate versions, all that stuff. So there was a really rough time going on. And before now come to the first Parachain test network, we had like 2 crashing issues before we could launch this network. There were one state with mismatch that only occurred after you had your Parachain running for a long time, and you needed to be very lucky that it was running in some certain state where it was always failing. And then we had like problems with syncing blocks between the Parachain nodes. So first I want to start with the state root issue. So what is actually a state root mismatch? So when you build a block, the block builder calculates the hash over the state, and this hash is put into the block header. And each node that imports this block checks that after the block is imported, that the hash of the state is equal to the one in the header. If it's not equal, that means there is some non-determinism in your runtime, and that's bad, and you need to fix it, because it's always expected that the same state with the same transactions gives you the same output. Otherwise, blockchains don't work. So in our case, the mismatch was only occurring when validating a proof of validity block. So we were really lucky that as we started our test network and let it run for like for a week or whatever, that it was running into the state. And the good point of the state is if the Parachain was once in the state, it was always failing. So we could take that and reproduce it and debug it. But it was like 10 to 40 days, frustrating days of debugging. It was really hard. So we were starting with okay, what's the problem? Maybe it's a compiler. So why do we thought it's a compiler? Because you could change certain lines, recompile the WebAssembly code, and it was working, or it was not working. And so, and we thought, okay, when you change code and it breaks the execution, maybe the compiler. So we took multiple compiler versions, spoke to compiler guys, recompiled compilers, disabled some stuff and all that things. But in the end, okay, it was always like, it cannot be the compiler, because even the same compiler versions with some different compilations, it always ended in this problem. So what we were doing the next days was like, we were building a working wasm file, a non-working wasm file, and then we were like comparing the operations that were executed and comparing the results of the operations, so that we could narrow down the bug. And then we looked at the opcodes of WebAssembly, then we looked into Rust code and tried to reproduce what was happening. And then after a long time, we finally found it. It was like the order of the input data for calculating the state root. It was different between the building side and the validation side. And the difference came because on when building, we were using native, and on validation, it's using the WebAssembly version. And the native side used a B-tree map that always was sorted, and the native side and the WebAssembly side used a hash map, and that could be different on the order. So, and the fix was just 2 lines, and it was like, yeah, okay, 2 weeks of work for 2 lines for sorting some data. So now to the sync issue, it was so if you have your So, if you have a blockchain, you're building blocks, and the other nodes need to be aware of this block. So what happens is we have these sync protocol, and that's already built into Substrate, which tells the other nodes, okay, it's a new block, and then the other nodes can say, okay, I want to have it. Now, Parachains are special, as you could have these like million collators, but you cannot import 1 million blocks because it takes too much time. So you need to reduce the number. And the good is that the relay chain already does that job for us because it already reduced the number from 1 million to, like, as I said, to 5, to the number of Parachain validators. So what we're now doing is the collators are waiting until with the announcement of their block until they get a special message from the Parachain validator telling them, okay, I validated your block, it's valid, and it's very likely that it will be included in the next relay chain block. So it's the next canonical one. Then the collator can or takes this message, appends it to the block announcement, sends it to the network, and the other nodes can verify this message because the message itself is signed by the Parachain validator. And if it is okay with it, it requests the block and imports it. So now the problem was that we had unit tests, but as you always know, between unit tests and the real world, there's often a difference. So it was running in unit tests, but and also in our local test. But when you do it locally, we often had only one collator per Parachain, so you don't need to sync any blocks at all, or even if you're just running locally, network connection is better. So it was just working. So yeah, we could fix it, and we found some more bugs, and spoiler, we found even more bugs that are still there, but we have ideas how to solve them, and we'll fix them in the near future. So after that odyssey, we ended with Rococo. So Rococo was our first Parachain test network. It launched on the 4th of August this year with 4 included Parachains, Tick, Trick, and Track. After launching, we had done several runtime upgrades. One runtime upgrade was providing an on-chain module for Parachain proposals, which made it really easy for people to propose their Parachains and for us to approve them. And so we could, over the next weeks, let 5 community Parachains join. And we are aware of, or there are 2 Parachains which are still waiting to join. And there are a lot of people who test their Parachains local on the Rococo test network and still ongoing testing, all that stuff. So now a recap of Rococo. We could show that Parachains are working, or that the proof of concept implementations is working. We could show that you can send messages between the relay chain and the Parachain and Parachains itself. We could even show that you can run a smart contract on a Parachain on a smart contract on a Parachain. And we could do Parachain runtime upgrades on this Rococo network. But on the downside, we could only register like 8 Parachains in total, because the problem was that the Parachain inclusion was slowing down. We were not doing any real analysis because there was already the Parachains we want on the horizon, and there wasn't any justification to spend time to fix these old code when you know that there's already the new one. So what is now the future? We will hopefully retire Rococo V0, hopefully kill it with fire. And from the ashes there we will relaunch Rococo V1 with Parachains V1 included, and we will probably find bugs, fix bugs. Depending on the bugs, we will need to relaunch a second, a third time, or whatever, how many times. But after that, if we are certain that it works, we will start the release on West End. After West End comes Kusama, and then Polkadot. And after landing it on West End, Rococo will probably be retired forever. Maybe we'll come back at some point, but that's for the future. So thank you for listening, and I will be in Discord for any questions. So we will see.
Thank you so much, Basti. Yeah, we just come to time at 20 minutes, so there's no time for answering the questions here, but please join Basti in the Discord channel and you can start asking him more questions about Rococo and the testnet from there. Great. Thank you. I'll see you in the next session.